Okay, I will continue now and give you an overview of future business opportunities. And mainly I will concentrate what we're doing and how do we operate our satellites. As I said, we've already approved the MTG program, and the facilities which we need for that are mainly already procured. There's one big facility which is still open. But I thought even there's only, for a big facility, only one more opportunity. I still would like to go a little bit more deeper into the ground segment area, that you understand how these things are coming together to us, because EPSSG, the next program, the big procurements will start in 1 year from now, also in the ground segment area. But independent of that, and Patrick will also explain that, we also have other procurements. It's not only everything dedicated to ground segment, we procure everything outside what we need for the ground segment, from toilet paper to everything. We put ITTs out. And the important thing, compared to ESA, we don't have a geo-return system. So, you know, ESA, you put a certain amount of money into an ESA program, they guarantee you get at least 90% back. We don't have that. So Patrick will explain more in depth the procurement rules which we have, which are open competition. There's no dedicated country which have to get something. We buy best value for money. That is the principle which we have, and Patrick will discuss this a little bit more. So I start with the overall system configuration, which is quite similar for both programs, for EPS and MSG, or MTG and EPS second generation. So basically we have a space segment with the 2 satellites, which not only have instruments for meteorological observations, but we also host other payloads. We have a search and rescue beacon. These are beacons which you find on ships, especially on sailboats who go around the world. If they have a distress situation, they press the beacon. We receive the signal in the geostationary orbit. We transmit it to the ground segment, which takes care of these systems, which is called Argos. And there are also little data acquisition systems, BUYOs, little data acquisition systems which birds take, which could connect to our satellite and deliver the data, which is a secondary payload and not our main purpose. But we offer the service which you see here, so search and rescue and data collection. So, and then we have basically 2 areas in the ground segment. The one copes with the control of the satellite, and the other one copes with the data observed from the satellite, the downlink of the data, which are then processed and distributed to the member states. So that's why we always have two antenna systems, one for telemetry and telecommand, which is basically in the S-band, and a mission data acquisition system. And because of the amount of data, we have a big change with MTG. We go in a factor 100 of data volume per day, which is a Ka band receiving system to allow us to receive all the data which is sensed. And then in EUMETSAT we have the satellite control center, the mission control center, product processing facility, data center archive where all the data are archived, and the dissemination to our users. So this is basically the setup, how these things are done on ground. And for all these facilities, we procure them outside. We don't develop ourselves. We set up the requirements for the procurement, what we call the statement of work, on which industry and companies are bidding, and then we have a tender evaluation process, very normal like in other countries, other institutions, or also in companies where you have an offer. You look at it, this is value for money, are you taking it or not? So, I briefly touched it before, which is again important. ESA is only responsible for the satellites. So the development of the first 2 prototype satellites and the recurrent satellites which we pay And our responsibility, again, to repeat that, we have the overall system responsibility. We have to develop the ground segment end-to-end and support the in-orbit operations. So all the 24/7 support in the control center is with us. We procure the recurrent satellites. We procure the launch service. We buy half of an Ariane 5 or full Soyuz. We procure the LEOP service, that's the initial time after the launch into the orbit position, which is called LEOP, launch and early operations phase, which we procure outside. And once they have put the satellite in the position, we take over. And then we do the full routine operations, and which is equally important over a 20-year system, the maintenance of the system, especially in the computer area. I think we are phasing out now the last, some of you older people probably remember the VEX VMS systems, digital equipment. When I was young, it was very important. It's all gone, but we're still, over a 20-year lifetime, we have to phase them out. So there's a lot of maintenance activities, and maintenance costs are quite high actually. They're quite a huge amount of our budget. And the last point is the satellite application facilities. There we use the expertise of our member states to develop further products. So we have 10 satellite application facilities for hydrology, for ozone, for numerical weather prediction, which are in our member states, which are co-financed from us. So the member states pay 50%, we pay 50%, and they produce additional products in their sites, which are also operational, which is quite important for the users. So I don't go too deep into that, just to show you how big a satellite is. It's really, this is a northern German woman, which are not small, so it's quite a huge, it's a 3-meter satellite. Up here, this is basically what we call a baffle. That behind that is the imager. You have to make sure that you don't have sun intrusion from the sides. That's why you have a 1.50 meter baffle in front of that, and it's quite a huge satellite, roughly 3.8 tons heavy wet mass, so with all the fuel inside for at least 10 years of operation of the satellites. And then I discussed already briefly the payload. I will not go back into this again. So this is a more detailed view of our MTG ground segment. At the top again, you see the satellite configuration, which is important, that we need 2 satellites for the operational dissemination. We use one for the full Earth disk, who looks at the full Earth, and the second one for the rapid scanning. So we need always 2 together for the rapid scanning and the full Earth disk. And then you see here the TTNC, telemetry and telecommand. It's basically housekeeping the satellite, looking how it performs, controlling him, putting him in the right position. That's the steering of the satellite, basically, to keep it in the position. And then we have here what we call the mission data acquisition in Ka band. And it's the first time we go to Ka band, which has some limitations. If there are strong thunderstorms, Ka band antennas, Ka band frequencies, which are in the 25 gigahertz area, are very strongly attenuated by thunderstorms. So you can lose the connection. So when we put the statement of work out, we ask for 200 kilometers, we ask for 2 antennas, so you don't have the same thunderstorm over the same position on both antennas, which is quite important, that we always have the mission data acquisition. Then down here, what I said, you have the mission operations, it's basically controlling the satellite, and then the instrument data processing, the IDPF, what we call IDPF. And we always differentiate between level 0, level 1, which is basically calibrating, very broadly, calibrating the raw data, the counts which are coming from the satellite, the bits and pieces, calibrating that, making radiometric corrections, and what we call the level 2 products, which are really physical values, which describes the status of the atmosphere. And we always we procure basically the level 1, which is very close to do the level 1 processing. You have to understand really the ingredients of the instruments. For the level 2, you have to understand the physics more. So level 1 was this time the first time we gave a direct contract to the space industry who was developing the instrument, because they have the best knowledge of the instrument to do that. And the level 2 processing facility is open competition. And then, which is quite a huge infrastructure in our house, is a dissemination system where we disseminate the data to the users, which is, as I said, over EUMETCAT. We're also using much more what is called GIANT. That's the European high-speed, correct me, scientific network, which doesn't guarantee the availability which we usually ask for. Yeah, there's limited, but it's very, very useful. So for data which are not time critical, we're also using GIANT now in the future. So we are part of the GIANT network, what I understand, which is an academic network in Europe, which is supported by the EC, and this we are using also. And then we put also our data into the WMO system. The WMO has a policy for essential data. Everything which is essential data for the Met service is free through the WMO network, which is called the GTS, the Global Transmission Service, I think it's the name, which is down here. So dissemination is quite an important thing. And also here we have very high requirements on availability, because we have to make sure if we have a high availability in the design of the satellites and the ground segment, but nothing end-to-end, then it doesn't help you. Huh? So we have to really look end-to-end to the users that we can guarantee this data. And then there are certain functions, backup control center. So hopefully we don't have an earthquake in Darmstadt, but if it happens, or a fire, we have always a backup control center far away from us. We have one in Spain, in Maspalomas, in Chaya, in Romania, in Italy, so that we can guarantee at least that we can control the satellites. That we cannot disseminate the data anymore, but we have to make sure that our asset in orbit is still working. So for the procurement approach for these huge systems, ground systems, we had several approaches in the past. We had one approach because we're already in the second and third generation. In the first generation MSG, we defined every little facility ourselves. We had a lot of facilities. We put out the requirements ourselves, got the facilities, and integrated them ourselves, which with some real problems when doing it ourselves. Then on EPS, we decided we didn't do very well on the first approach. Now we give it to a prime contractor. So for EPS ground segment, we gave it to a prime contractor who was responsible for everything, for the antennas, for the level 1, the level 2, and the dissemination part we always did ourselves. So also that showed some problems, because the prime contractor was very strong on level 1 and level 2 and satellite control, but not so strong on the antennas, because it was not his core competence. So we also learned something. Now on MTG we tried a third approach. And for EPSSG you will see what we're going to do. For MTG we have divided the facilities in 3 areas where we can have the expertise industry on that. So we have one procurement for the antennas, for the TTNC and the MDA. We had one procurement for the level 1 processing, and we will have one procurement for the level 2 processing, to really have the expertise industry together. For EPSSG, it looks like we will do a third approach. We will put the mission data acquisition and the level 1 together. We will put the TTNC, level 1, level 2, and we will put the telemetry and telecommand together with the mission operations facility which controls the satellite. So we have a third approach. We will learn every time, so you'll never find out the best, but you have to try. So it's a little bit closer look in the depiction of the ground segment. You've seen that on the left side again, we have the space segment. Don't be confused by all the abbreviations. I'm also confused actually with all of that. We have too many abbreviations, it's an incredible thing. So again, you have the mission data acquisition, the KA band here, and the TTNC for the control of the satellite. And then level 1, what we call the instrument data processing facility, which does the basic all data processing. the level 2, which takes the data from the level 1 and go and process it to higher physical values. The mission operations facility, who is doing the control of the satellite, ground station, and we have always had the possibility to see from our system what is the health of the ground station, which is not around the corner, which is far away from us. And then we have network management. And then we have a lot of engineering functions. That's why I'm using this graph also, this view graph. So we need offline analysis. We have to see, we have what we call an IQT, an instrument quality tool. We have to see if the data which is coming down is according to the specification. So you need offline evaluation tools, which is very important. Then you also need a backup ground segment. If you have any software changes, you have to test it. So we have always what we call an operational environment and an engineering environment. So if you buy a ground segment, we always have 2 instances of it. That if we have any software changes to the ground segment, we have to test it, and only then, once we have validated and verified the software change, it is transferred to the operational environment. So we have always several instances, what you would call a development environment. And which is down here, the reprocessing function. So if you have a new system, you have to learn to calibrate the instruments, how you do that. And with the time, you're getting much more expertise on that. So you know much better how to remove the bias, how to do the radiometric corrections, the geolocation. So at the beginning, you are like a beginner with a new system. After 20 years, you are the expert. So what we are doing, we are taking the old data from the beginning and reprocess them according to our newest knowledge. That's a reprocessing environment, which is also very important for any data set which we deliver to the climate environment, to the climate assessment, because you have bias changes and you have to have something like a standard against which you calibrate. So this is a reprocessing environment which we do constantly in the background. Even we are now just reprocessing data from MSG, which is 10 years old, to have the best calibrated data without any jumps, which is important. If you see any jumps in the data, in the temperature, suddenly you have a jump, is this climate change or do you change the bias? So it's all these questions which you have to handle. So this reprocessing environment has to have the same throughput as the original thing, because you cannot wait 4 years to get all the data newly processed. So quite high requirements on the reprocessing, but not on the availability of the environment. Just to show again a little bit how the payload flow. So we have here on the left side the mission data acquisition. We have the raw data. Just to explain that again, it goes into the instrument data processing facility, level 1, which then goes to the level 2, higher level products. I will show some examples what it actually is. And we have an offline environment for analyzing, reporting, quality measurements, and so on. And then we have the data center, which is basically the archive, and the dissemination, and the reprocessing. That's basically the environment on which all our ground segments are working, because you have different engineers in your organization that do it always a little bit different. We try to harmonize and have a common approach to certain functions, not to invent everything the wheel again. Traditionally, if you look back 10 years, we had the GEO program, we had the LEO program, and they went their way, and now we are trying to come up with a multi-mission environment, because we have so many missions, they have same functions in all the missions, we have dissemination, so we have a multi-mission layer, and on top we connect to special applications which are dedicated, which are very special for MTG or very special to the LEO programs. So we are now moving really in a multi-mission environment to reuse things, and software IPR is very important for that we can reuse certain things, and particularly we will also probably say something that's a very important point for us, IPRs. Now, as I said, there's only one big facility still open, where the ITT will come out in the coming weeks. It's the level 2 processing facility for the MTG system. As I said, it will contain, it calculates estimates of geophysical parameters, which are then disseminated. And there's a near real-time requirement. So we cannot wait for hours. The level 2 products are coming out, so there's a very clear requirement on throughput of the system. And the input comes from the IDPFI. We also need auxiliary data from ECMWF, parts of the data which we need to generate these level 2 products. So what are the level 2 products? Just some, and I know we have 2 methodologists with us who knows this, cloud mask and cloud analysis, optimal cloud analysis. You see, look at the top of the clouds, the pressure, the temperature, clear sky reflectance, fire identification. We have a very sensitive infrared channel who can depict, we can find fires on ground, all sky radiances. GII is a global instability index, so it's very interesting. It's a map which shows you where you think a thunderstorm could develop. There's a instability. If you have a very high pressure system sitting on top of us, the air is very stable. But if you have other air coming in, which is unstable, it can develop clouds can develop into thunderstorms, and it gives you an index where you think these instabilities will happen. And there are physical parameters on which you can depict that where it happens. And the atmospheric motion vectors, I explained that before. For the lightning, we are looking at clusters, lightning events, the number of flashes which we see. And what is important with the lightning detection systems, there are also lightning detection systems on ground which looks at the frequency in the long wave band. You can hear it in the radio. If you have a lightning strike quite near to your radio, or not too near but far, you hear a noise in the radio. So these frequencies which you hear in the radio you can depict and find out where the lightning is. So the ground-based lightning systems, but they don't cover all lightnings which are there. So we're looking at an application where we use these ground-based radars and high-frequency receivers together with the data which you get from the satellites, and to have an improved warning time. So on the IRS, just an example, what is a level 2 product? Atmospheric temperature profiles, so the temperature distribution over the altitude, humidity profiles, surface states. This just gives you gives you some idea what a level 2 product is, and here what we discussed before, atmospheric constituents, which are derived also out of the measurements. As I said, it will be procured as a single facility, OpenITT. It should have a framework software and an application software. So the framework software, basically, I'm not an IT specialist, so I have to read that. The framework software really distributes the task and makes sure that in the real-time requirement in processing the data is doing. And it has to be very flexible, because usually during the course of the development we add additional products, so it should be easily expandable. And the ITT is expected for the second quarter of 2014. I asked my people just some. It's really a high computing environment, so we are talking about several tens of teraflops, which we're needing more than 1,000 cores. And we have roughly a terabyte of data throughput a day. So it's quite a heavy computing environment, which you should be aware of. So we still have other ground segment procurements which are coming, and we have a web page, Patrick will show that. We have to upgrade our network, so normal Ethernet cables, and we have to have new servers and all that you can find there. Then what is quite important, we also need support. So if you look at our distribution of employees, the core knowledge which we have in our organization are staff members, but we always need support by special expertise. So we have half of the employees are contractors, where we put out statement of works for certain expertise. And we need a lot of consultancy support also in the integration part. So we need engineers supporting us when the system comes together, do the tests, the validation, the verification, the test data generation to support us. And here's a table. We are already in 2014, but you see we are still looking for quite a number of support people over the years, depending on the state of the program where we are. So it's not only that we procure goods, but we procure brain also, which supports us in our daily work. So very briefly on EPS, two-satellite configuration, I showed that main application, nowcasting at high latitudes, marine meteorology, numerical weather prediction, operational hydrology, air composition and climate monitoring. I don't repeat that, you have seen that before, two satellites with, on the first satellite we have more the passive instruments, and all the microwaves, the active instruments in the microwave area on the second satellite. And here I didn't explain that, this is the scalerometer, and you need these little helicopter antennas to depict the wind direction. If you have only one antenna, you cannot depict the wind direction, and this is on the second satellite. So briefly, it's the same thing what you have seen on MTG, S-band for telemetry and telecommand to control the satellite. Same thing on KA band. Because of the huge data amount, we have to go to KA band for receiving the signals, the mission data. Then we have a very special feature which is important. You see here, when the satellite comes over you, you have the possibility to have a direct broadcast from the satellite from the latest sense data. So if you have a receiving station in X-band, which is called the EARS, EUMETSAT RTOF retransmission service, and you have an X-band antenna, you get the latest data when it flies past you with a strip of 5,000 kilometers times 3,000 kilometers. And you can then get software from us to use this data immediately for the forecasters. And this is a very special feature which we only have on the LEO satellites. And then what I discussed, what I explained before, you have the mission operations, which basically controls the satellite, the level 1 and level 2 data processing, data archive, and then dissemination over EUMETCAST, satellite application facilities, external user organization. So it's basically the same thing. I'm going so deep into that that you really understand how these things are coming together. If you read our website where the ITTs are specified, that you understand really what it means a little bit, what we are using. So currently on EPSSG, we are currently in phase B, so we do the preliminary design of the overall system. We have done a system requirements review. The system requirements review you do to verify that the requirements which you have are really fulfilled in the first part of your preliminary design. And we are currently doing the first part and the second part. And that was also an input to the ESA ITT on the METOP SG satellites, which is now the TB is finished. The industry has given the offers, and I think on the 12th of April there's the Industrial Policy Committee in ESA who will decide who will be the winner. And as I said, for the ground segment approach, we are currently under definition. We will present a paper to our delegations, where your delegate has a saying if he is happy with the procurement approach. And as I said, probably we do a combination of what we have done before. We will combine the TTNC with the mission operation facility and the mission data acquisition, the KA band together with the level 1, level 2 in one procurement. And there are a lot of scientific studies. So if you have expertise in the scientific meteorological area, we have a lot of need for all our instruments to better understand certain questions. So we are putting out scientific studies. They are roughly between 60K to 150K depending on the size. And these are open competition, and you can also go for that. And we need a lot of consultancy support also for that program. Where are we today in the decision on the EPSSG program? Basically, in the lower line we see the EPSSG preparatory program where we are, which runs until mid of 2015. And what we put to our council in the summer, the EPSSG program proposal. And we hope then this program can start at the beginning of next year. Because ESA then in parallel will make a decision on the satellite in the coming weeks, and then we have to be synchronized with the satellite development with our ground segment. And we are looking for a date for launch end of 2020 for the first satellite, and then 2 years later the second one. JNCS, which is a continuation of the sea surface topography mission. We look at sea level change. We have proposed, we are still in the proposal phase to our member states of 2 satellites, and first one to be launched in 2019. ESA develops again the satellite. It's based on the Curiosat heritage, and our ESA's responsibility will be to develop the satellites, both of them, give us the instrument data processor. We will do again the ground segment, the same setup as with the other programs. We will develop the ground segment, but here we are in a very early stage with the program, and we will operate the mission. We have a coordination with NOAA. They are on board, they're delivering some instruments for that, and they will do the launch service and also support the operations. And as a hopefully later statement, there are business opportunities in EUMETSAT ground segments during development, exploitation phase, facilities, which I've explained, engineering support, maintenance and evolution of the operational infrastructure, a lot of scientific studies, and we expect big procurements in the 2015-2016 timeframe for EPSSG, and probably also for JNCS if we are lucky, if our member states have enough money, also for JNCS in that timeframe that we go for the procurement. So this is my presentation, and Patrick will give you now much more information on how to make business with us. If you don't have any additional questions, which I'm